I will discuss about the superposition principle, that is superposition theorem. I will read out the statement. What is the statement? The statement is, for a linear bilateral active network consisting of two or more than two sources, this principle or this theorem is applicable to the circuits which consists of the at least two sources or more than two sources. What is the theorem? Current or voltage at any point in the network is algebraic summation of the current or voltage at that point when each source considered separately. By that time, remaining all sources are replaced by the respective internal resistance. First, I will explain what do you mean by this theorem, and then we will try to understand its working principle. I will discuss this particular theorem with very simple example. How is the case that I am trying to show here? I will put here the definition as it is, and then I will discuss about this theorem. Is it right? This theorem, and then I will go to the complicated figures. Now look at carefully. So if we have figure something like this, I will take one example, and through that example we are trying to understand what do you mean by the superposition principle. Suppose we have very simple circuit. Here it may be the 10 volt, this may be the 5 volt, this may be the 5 ohm, and we are interested in the calculation of the current in 5 ohm resistance by using superposition theorem. I will discuss what do you mean by the superposition theorem. Current or voltage at any point means we are interested in the calculation of current in this branch. Current or voltage at any point in the network is algebraic summation. This is important. Algebraic. Algebraic means summation with sign or summation with polarity. Algebraic summation means summation with sign or summation with polarity is expected. Polarity in the sense is direction for the current, and polarity means plus and minus. It is expected for the voltage. First, I will discuss about the current. Means direction of the current is important. Is it right? And every time it is algebraic summation of the current or voltage at that point when each source considered separately by that time. Means at a time we are considering only one source. Then second time we will consider the second source and we will calculate its current. Means what we are going to do? First we are considering the first source, we are calculating its current, its direction. For second time we are considering its source and we are finding its direction. And as per the direction, we are finding its summation. If the direction is same, summation means it is addition. If the direction is different, algebraic summation means it may be the subtraction. Is it right? The current or voltage at any point in the network is algebraic summation of the current or voltage at that point when each source is considered separately. This we have to consider each source separately. By that time, and remaining sources are replaced by the respective internal resistance. This source could be replaced by its internal resistance, this source may be replaced by its internal resistance. That point is important. Now here, what is important here? Internal resistance. Internal resistance. What is the internal resistance of the voltage source? And what is the internal resistance of the current source? Internal resistance of the current source. Internal resistance of the current source. And this is voltage source. How much? Can anyone is able to answer this question? Internal resistance of the voltage source and internal resistance of the current source. We have discussed in the unit number 1 itself. Ideal voltage source. How much is the internal resistance of the ideal voltage source? 0 ohm. And how much is the internal resistance of the current source? Infinite. Be careful about these 2 points whenever we are discussing about this theorem, which is the superposition theorem. Means internal resistance of the voltage source is 0. This voltage source should be replaced by short circuit because short circuit has 0 resistance. And internal resistance of the current source is infinite. Infinite means it is open circuit. When we will get about the current source, I will discuss. So here in this case, we have to calculate current in the resistance that much number of the times the number of sources available in the network. Means if we have the 2 sources in the network, we have to calculate 2 times current in this case. First by considering 10 volt, then considering by 5 volt. Means what I will do, I will consider here the case 1. Try to understand the philosophy first. Don't write anything. Case 1. In the first case, we will consider this first source and we will replace the second source by its internal resistance. How much is the internal resistance of the voltage source? 0. That's why it is replaced by the 0 resistance. This is 5 ohm as it is, this is 10 volt as it is. Now look at the direction of the current. It is forward, in this resistance forward. And always we will get the true direction of the current in this case because we have only single source at a time. If we have the multiple sources, we have the confusion about the direction of the current, but whenever we have the single source, we are able to calculate its actual value of the current. Now here in this case, in the first case, I will name it as I1. Current in the 5 ohm resistance for first case, that is for 10 volt source, I will name it as I1. Is this current is I1. Then how much is the value of I1? Total voltage divided by total resistance, that is 5 to the 10, that is 2 ampere is the current. And how is this direction? This direction is the forward because algebraic summation. We are interested in algebraic summation. Summation with sign. If both are in the same direction, we will add. If both are a different direction, we will subtract. Is it right? Then case 2. In second case, we will consider the second source. Is it right? The circuit will be the same. We will consider the second source. Is it right? And this first source is again voltage source. And that source should be replaced by its internal resistance, which is 0 ohm. This is 5. This is 5 volt. This is 5 volt. This is 5 ohm. And this source is replaced by its internal resistance in the case 2. Now look at the direction of the current. Current is always flowing from the positive to negative. Positive to negative. Not like this. Positive to negative. I said positive to negative through the circuit. If circuit is something like that, then current will be flowing in this way. That is positive to negative through the circuit. This positive to negative, something like this. This is direction of the current is something like this. This current is the I2. Is it right? For the second case. How much is the I2? I2 is equal to 5 divided by 5. How much? 1 ampere. How is the direction? Something like this. If it is taken as a positive direction, this should be the negative. Sign conventions are not fixed. We can assume the sign conventions of our choice. Is right. That's why in this case, the total current I, or I will call it as IL, load current, is equal to, this is I1 minus I2. And in this case, this is 2 minus 1, which is equal to 1 ampere. The discussion of this original case. And I will again, after this, I will discuss the problems based on this. For a linear bilateral active network consisting of 2 or more than 2 sources, current or voltage at any point in the network is algebraic summation of the current or voltage at that point when each source considered separately. By that time, remaining all sources are replaced by the respective internal resistors. This is the statement. Now here in this case also, first find out the load resistance. This is our load resistance in this case, RL. Now look at how many voltage sources or independent sources we have. Here we have only the 2 independent sources. Means here will be the 2 cases. I will write here first case 1. I will write case 1. I will write some statement here. In first case, we will consider source V1. By that time, source V2 is replaced by its internal resistance. This is the statement because examiner has to follow what you are trying to do. आप क्या कर रहे हैं उसके लिए लिखना है. In first case, we are considering this first source and we are removing the second source or all sources. यहाँ पे 2 ही है इसलिए second source. By its internal resistance. How much is the internal resistance of this voltage source? 0. Then draw its figure for first case, that is case 1. I will draw its figure somewhere here. This will be the figure. Is it right? Means every time we have to reduce the network, and in this case you are able to understand the series and parallel combination in better way for this particular theorem. This is the case. Is it right? Now if we know this figure, then try to reduce this figure. Try to reduce this figure because we are interested in the calculation of the total current. इस figure को हम अगर reduce करते हैं, in that case these two branches are in parallel combination. Is it right? How will be the next figure? Next figure will be something like this. Next figure will be something like this. Is it right? This is RP1 for first case. RP1 because we are discussing about case 1. This resistance R1 is the same, this source V1 is the same. This is as it is, this is as it is. Its parallel combination is RP1, and what is the RP1? RL into R2 divided by, it is RL plus R2 is its value. Is it right? Now look at how is my approach. My approach is, first we will calculate the total current in this loop, which is I1 for first case. Where is this current is known? Current is known from the battery. This current we are calculating, current from the source. This is I1. We are interested in current in this branch. I will call it as IL1, that is load current 1. And then we will use some formulas and we are trying to find out its value. First find out its total current, that is I1. Now here its total current I1 is equal to, what is the formula? Total voltage divided by total resistance. Total voltage is V1. It's figure mein. Total voltage is V1. How much is the total resistance? Total resistance is R1 plus RP1. And we are able to calculate its value of the current if the values of V1, R1 and RPM are known. Is it right? With this current I1, we can find out the value of IL1 directly. We can find out the value of IL1 directly by using current division rule. I have discussed it previously, still I repeat here. What is the current division rule? I am discussing here. Generally we will have the two rules which is having the lot more importance. That is, one is the current division rule and other is the voltage division rule. Right now I will discuss about the current division rule. Suppose this is R1, this is R2, and here is the total current which is I. If this current is known and values of these resistances are known, we can find out current in any branch. Suppose we are interested in this I1. Look at the formula. I1 is equal to, how is the formula? This current division rule I am discussing. Current in this branch, that is I1 is equal to, figure में भी नाम देना है. We have to give the names in the figure. Otherwise, the other person which is trying to understand this may get the confusion. Is it right? This I1 is equal to, what is the formula? Total current into, total current is this I, into resistance of the opposite branch. ये दो parallel branches के लिए apply कर सकते rule. ये दोनों में से इसमें current निकालना है, तो opposite branch हुआ ये R2. Current in the opposite branch divided by resistance of both branches, that is R1 plus R2. This is the current division rule. Is it right? Now suppose I will repeat the same rule for I2. If we are interested in the calculation of the current I2, how is this rule? Look at carefully. In this case, again the formula is the same. Total current into resistance of the opposite branch. Total current is I. Now in this case we are interested in the calculation of current in R2. In this case opposite branch will be the R1. Means into it is R1 divided by resistance of both branches, that is R1 plus R2. This is the current division rule. Means what I am trying to do here? This first I have calculated this I1 here. And by knowing this current, this is one branch and this is parallel branch, and these are the two parallel branches. We can use the same rule and we can find out the value of the current in that particular branch, which is IL1. Look at carefully here. How is this current? IL1 is equal to, or current in this branch is equal to, what is the formula? Total current. Total current is I1 into resistance of the opposite branch. In this branch, current is known. In this branch, current is known. I am not bothering about this branch. Now, out of these two parallel branches, in this branch, we are interested in the calculation of the current. Means this resistance is R2. This into it is R2 divided by. इसमें current निकालना है तो इसको consider करना है. Is it right? So here we are interested in this. That's why opposite branch will be the R2 divided by resistance of both branches, which is nothing but RL plus R2. And with this, we are able to get its current IL1. And how is the direction? Its direction is downward. Its direction is downward. That's why its direction I will mention it as a downward. Is it right? This is about the case 1. Similar procedure we will do for the case 2. Is it right? Here I will consider the case 2. Is it right? Now I will write here case 2. Case 2. I will write the similar points, whatever I have considered here. What are the points I have written? In the second case, we will consider the source V2. In case 2, we will consider source V2. By that time, what? I will show the figure. This is something like this. This is my figure. By that, I will, first we have considered the source V1 in case 1. Now I will consider source V2. By that time, source V1 is replaced by its internal resistance. Is right. Its internal resistance. Then how will be the figure for case 2? How will be the figure for case 2? Case 2 के लिए figure कैसे होगा? Just here I will consider this source, and this source should be replaced by its internal resistance, that is 0 ohm. This figure will be something like this. This is the figure for case 2. Try to understand. Is it right? This source is the V2 as it is. This is R2. This is RL. And this is R1. And here this source is replaced by its internal resistance. This source is replaced by its internal resistance. And then we will apply the similar procedure here. And we will try to find out its current in that particular branch. Is it right? This is our figure. Is it right? Now here we have taken this case 2, this source, and we have replaced this source. Again, this is the voltage source. It should be replaced by its internal resistance. Is it right? Now how will be the case? Now again we have to reduce this figure. Whenever we have the source on the left hand side, something like this, from left hand side, the circuit will reduce from the right hand side. It is something like this. If we have the source on this side, circuit will reduce in this direction. But whenever we have the source on this side, circuit will reduce in this direction. First, I will draw its new figure, its next figure. If I am trying to draw its next figure will be something like this. I will draw its next figure. It will be something like this. These two resistances are in parallel combination. I will call it as RP2 for the second case, and remaining part of the figure is the same, that is as it is. This source is the V2, this is R2, and this RP2 is nothing but it is R1 into RL divided by, this is RL divided by, it is R1 plus RL is the resistance. ये दोनों parallel हैं. Look at starting point is connected together, ending point is connected together. इसके बीच में कुछ नहीं है. That's why these are two in parallel combination. This RP2 is the value. Now try to find out its total current. I will name this current in the figure. हमेशा current कैसे flow होगा? Positive to negative through the circuit. Means something like this. Actual current. I2 is the current for case 2. In this figure, where is the total current? total current is from the source, which is I2 is here. Is it right? And we are interested current in this branch, which is IL2 for case 2. The first find out its total current. If we are finding its total current, that is I2 in this case, this current, how is the formula? Total voltage divided by total resistance. Total voltage is V2 divided by total resistance is R2 plus RP2. We have got the total current. If we have got the total current, then try to find out current in this branch. The total Miller, come to the previous figure and find out this IL2. Now, this IL2 is equal to, how is the formula? Use the current division rule. Current in this branch is already known. We are interested in the current in this branch, that's why opposite branch will be this. How is the formula? Total current, which is I2, into resistance of the opposite branch, which is R1, divided by resistance of both branches, that is R1 plus RL. This is the formula, and we are able to find out its current. Now look at the direction. How is the direction of this IL2? It is downward. Is it right? And how was its direction in the case 1? In the first case, its direction was something like this, which is downward again. Is it right? In both cases, the direction of the current is the downward. In both cases, the direction of the current is downward. This is downward as well as this is also downward. In this case, this is also downward. Means how is the resultant case? Therefore, current in load resistance is equal to, दोनों का direction same है, it is IL1 plus IL2, and this is the final formula for superposition principle. In this way, we are able to find out current in this branch.